Dear students, today we will see the topics surface areas and volumes of 3D shapes. We know that this we have studied already in our 9th standard. So first we will recollect all the formulas what we have studied early. First we will consider cube, cuboid and cylinder. There is a reason for selecting these three solids alone first, because we know that for cube, cuboid and cylinder, its top and bottom are in same size and shape. Solids with the same size and shape, we have an easy method to remember its formula. So considering the formula, we have CSA, TSA and volume. CSA is its curved surface area, TSA total surface area, and volume its capacity. So coming on to CSA, CSA is its surface area of its surfaces other than top and bottom, that is except top and bottom, the other four parts or the curved part, that's considered CSA. CSA is also known as LSA, lateral surface area. TSA is CSA plus area of top and bottom, that is the whole surfaces areas. First of all, we will see cuboid. Cuboid, we know that it is the 3D shape of a rectangle. So for rectangle we have a length and breadth. So first we will consider the base. The base part is in rectangular form and we have a length and breadth there. So its perimeter will be 2 into L plus B and area will be L into B. So to find CSA, as per our previous common formula, its base perimeter into height. So CSA equal to base perimeter is 2 into L plus B into height. So we can write it as 2H L plus B. Next is TSA. TSA is nothing but 2H L plus B plus area of top and bottom. Since top and bottom are in rectangular shape, the area will be L into B. So since we have two parts, it is 2 into L into B. So the TSA is 2H L plus B plus 2 L into B. Once we open the brackets and take 2 as common out, we will get the formula like this: 2 into LB plus BH plus LH. Volume is nothing but base area into height. So base area is L into B into height. So L into B into H. Next we will see cube. Cube is nothing but we know that it's a 3D shape of a square. So for a square, we know that the base is in square shape and its perimeter will be 4A. All four edges will be, we will consider it as length A. So it will be 4A and area will be A into A, that is A square, side into side. So considering CSA, base perimeter into height, here height also same measurement, so we are considering it as A itself. So 4A into A, we will get 4A square. TSA is equal to CSA plus area of top and bottom. Top and bottom is square shape, so we know that the area will be A square. So since two parts, it's 2 into A square. So the total surface area is 4A square plus 2A square, it is 6A square. Next, volume. Volume is base area, that is A square into height into A. So it's A cube. Or else for a cube, we can consider is CSA and TSA like this. That is, we have 4 surfaces in the curved surface, right? 4 faces. That 4 faces, each face have A square as area. So 4 into A square, we will consider it as 4A square. And for total surface area, we have 6 faces and each face have an area of A square. So it is 6 into A square. Either we can consider it like this, or as our previous formula, we'll get these formulas. Next, cylinder. Cylinder is the 3D shape of a circle actually. So the top and bottom are in circular shapes. for a circular, the perimeter is nothing but its circumference. Since it is a circular path, for perimeter we will consider the word circumference. So circumference of a circle is 2 pi r and its area is pi r square. So CSA is equal to base perimeter into height, that is 2 pi r into height, which is 2 pi r h. TSA equal to CSA plus area of base and top in circular shape, and its area is pi r square. So 2 into pi r square, 2 pi r h plus 2 pi r square. So taking 2 pi r common, we will get 2 pi r in bracket h plus r. Volume is base area into height. So base area is pi r square into height pi r square h. We will go through the formulas once again. For cuboid, the curved surface area is 2h L plus b. Total surface area is 2 into LB plus BH plus LH, and volume length into breadth into height. Cube, curved surface area 4a square, total surface area 6a square, and volume a cube. Cylinder, curved surface area 2 pi rh, total surface area 2 pi r h plus r, volume pi r square h. Surface area and volumes of cone, sphere and hemisphere. Cone, as we know, it has two surfaces, one base and one curved surface. Moving on to its dimensions, it has 3 dimensions, one height, one radius and one slant height. Slant height is nothing but the distance from the top to the circle on the base, which it is the longest distance, and it can be considered as hypotenuse in a right angle triangle, because H, L and R forms a right angle triangle. Consider the picture 2. In that picture, L is the slant height, H is its height from top to the bottom, and OB is the radius, because the base is in the form of a circle. So OB is its radius. Here H, R and L forms a right angle triangle. So if any two value is given and to find the third value, we can use the Pythagoras theorem. So here to find L, the formula will be L is equal to root of H square plus R square. Now moving on to its formulas. Curved surface area. So curved surface is nothing but the outer surface other than the base. So the curved surface area will be pi r L, and total surface area is curved surface area plus area of base. Base is circular portion, so it will be pi r square. So pi r L plus pi r square. Taking pi r common, it will be pi r L plus r. And volume of cone is, the cone is actually 1/3 portion of a cylinder. So the volume of cone is nothing but 1/3 of a cylinder, 1/3 into volume of cylinder, that is pi r square h. So 1/3 pi r square h. Next is sphere. Sphere, as we know, it has only one surface. So its curved surface area and total surface area will be same, which is 4 pi r square. And volume is 2. Volume we can take it as 2 times a cone. So 2 into 1/3 pi r square h. 1/3 pi r square h is volume of a cone. But here no height for a sphere, or the height we can consider as its diameter, because height is nothing but the distance from top to bottom passing through the center. So that will be its diameter, and that diameter we can consider as 2 times radius. So h is 2 times radius. So 2 into 1/3 pi r square. Instead of h we can give 2 times radius, 2r. So 2 into 2 it will become 4. 4/3 pi r cube. R square into r, it will become r cube. So volume of a sphere will be 4/3 pi r cube. Hemisphere. Hemisphere is nothing but the half cut portion of a sphere that forms the hemisphere. So hemisphere we have two surface, one is its curved surface and one base. So the curved surface area is straight half of the sphere. Sphere it was 4 pi r square, so here it is 2 pi r square, and total surface area will be curved surface area plus base. Base is circular shape, so pi r square. So 2 pi r square plus 1 pi r square, it forms 3 pi r square. Volume is as like the previous one, we can take it as 2 times a cone. So 2 into 1 by 3 pi r square h. So here h is its height, forms the radius itself, right? So instead of h we can give r. So the formula becomes 2 by 3 pi r cube. We'll go through the formulas once again. So for cone, curved surface area will be pi rl, total surface area pi rl plus r, volume 1 by 3 pi r square h. Sphere, only one surface is there, so curved surface area and total surface area will be 4 pi r square. Volume 4 by 3 pi r cube. Hemisphere, half of sphere, so curved surface area 2 pi r square, total surface area 2 pi r square plus pi r square forms 3 pi r square, and volume half of sphere, which is 2 by 3 pi r cube. So we have gone through all the formulas which we have studied already. Now we will study a new object and its formula. The object is frustum of a cone. Frustum of a cone is nothing but, if you are taking a cone and removing its top portion or removing from the center or something, the rest portion form its frustum. And for a frustum we have a height, a slant height, and two radiuses, one capital R and one small r, because here both top and bottom are circular shape but the size is not same. So the bigger circle we are taking it as capital R, and for smaller circle we are taking it as small r. And to find the slant height, the formula we have a slight difference, that is L is equal to root of h square plus r minus r whole square, that is the difference between both the radius and its square. So moving on to curved surface area. The curved surface area is nothing but pi r plus r into L, or we can consider it as pi L r plus r. Now TSA. TSA is nothing but curved surface area plus area of top and area of bottom. So CSA is pi L r plus r plus area of top and bottom. So area of bottom circular shape pi r square, and area of top also pi r square. So pi capital R square plus pi small r square. Volume is nothing but as like cone 1 by 3 pi h. Instead of r square we will take it as capital R square plus small r square plus capital R into small r. Along with frustum of cone, we are studying combination of solids also. So here some combinations are given. We'll just go through the figures. One ice cream is given. It is not just a cone shape. Here we have a cone shape and a hemisphere on the top. So here the figure given is one cone plus one hemisphere, and a tent. The tent, it is given a cylindrical portion, and above that one conical portion. So one cone and one cylinder is given. A capsule is given. Here one cylindrical portion is given, and both the ends it's given one hemisphere here and one hemisphere here. So a cylindrical portion with two hemispherical ends. The picture is given here. Is capsule, this like this, one cylinder and two hemispheres. Next, tanjore doll. Tanjore doll, here the shape is one frustum is given here, right? So one frustum, and top and bottom it's given two hemispheres. Since it is a frustum, here both the hemispheres are not same size. One is bigger one, the other is smaller one. Here one cone and hemisphere is given, cylinder with two hemispherical ends, cylinder with cone and hemisphere. Here hemisphere and cone, same cylinder and cone. Here two cubes are given which forms a cuboid. Now coming on to surface areas and volumes. If they are asking you to find total surface area of given figure, one ice cream cone is given here. So to find its total surface area, is it necessary to take TSA of cone plus TSA of hemisphere? No, because to find total surface area of this given solid, just imagine if they are asking surface area, it is nothing but to, if we are going to paint that one or to color that one, which all portions will color, that forms its surface area. That means only outer surface we are taking. So here for ice cream cone, to find its surface area or total surface area, we need to take only the CSA of hemisphere and CSA of cone. So if we take CSA of hemisphere and CSA of cone, we will get the TSA of this ice cream actually. Here also for to find TSA of this capsule, if you want to paint this one, we will paint only the CSA of cylinder, CSA of hemisphere and CSA of this hemisphere. So TSA of capsule is nothing but CSA of two hemispheres plus CSA of cylinder. Same like Tanjo doll. To find total surface area of this doll, we need to take only CSA of this hemisphere, CSA of this hemisphere and CSA of Frustum. But coming on to volume, it will be as usual. Volume of this ice cream will be volume of cone plus volume of hemisphere, volume of tent also, volume of cylinder plus volume of cone, volume of capsule, volume of cylinder plus 2 into volume of hemisphere, and so on. So hope you have understood how to use the combination of solids. Sometimes they will be giving the whole height of the given toy or given solid, total height, or sometimes they'll give separate, as so the cylindrical portion is this much height and the conical portion will be this much height, and so on. Here if we are taking two cubes together and attached it to form a cuboid, just remember that here only the length is getting doubled. That is, here it was 14 centimeter and two 14 centimeter cube are attached together to form a cuboid. So the length is just doubling in that cuboid, that is 14 plus 14, it will become 28, but to the breadth and height there is no change. So the breadth and height won't change, only the length will get double, because two equal cubes they are attached together to form a cuboid. So thank you for watching my video.